Hello, my name is Bob HIlster and I am your particle model guru. The particle model has three basic particles which will be used to describe all kinds of events from gravity, light, magnetism, electrostatics, circuits, and even chemistry. Today I'm going to talk about the interaction of these particles with particles or other objects. The first I'm going to talk about is the nucleon. The one event that is pretty clear concerning the nucleon is the atomic bomb. When an atomic bomb goes off, initially we get a flash of light. And this is just the G1 particle coming in high intensity towards you and in all directions. A flash of light. The second thing we can see, and although you probably see this more in the animations, is a wave of destruction that moves from the atomic blast outward again in all directions. What this is the nucleon moving at not high speed, but high enough such that as it meets an object, it literally smashes things to pieces. And the nucleon is often used in particle accelerators where they're used to smash atoms, sending what they call protons and neutrons into a target and smashing them. That's an interaction we don't like, but it's there and it happens. Then I'm going to talk about the interaction of the G1 and the G2 particle. Now, these interactions are very similar, so I'm going to first cover them in a similar way. And again, there are three main interactions that these particles have with other particles. There are a couple of others that we can talk about, but they'll come up when the time is needed. These three will be repeated over and over again as I describe gravity, light, and etc. The three interactions are simply this. The particle can pass through, it can bounce off, or it can get trapped by the object that it's passing through. So let's talk about passing through. Light passing through a mirror and pass through glass, pretty obvious. We can see light passing through that. In the particle model, light is a stream of G1 particles with a specific wavelength or random wavelengths for white light. It enters the glass, passes through the glass, and it leaves the glass. And the main reason it can do that is that there's a lot of space in the glass, wide open space that allows the particle to go on through. The second reason is the G1 particles moving at or around speed c, moving very fast. And so it has the room, and with the speed being pretty dominant, it can get through. Another reason it can get through is it's guided by the internal G2 forces which are holding the atoms together in the first place. These G2 forces hold atoms in a certain position, so the light can actually pass through an atom at high speed. It can pass between the atoms, but between the atoms is a force field holding the atoms together and guiding the G1 particle through. Much like an asteroid is guided through our solar system or through our galaxy. G1 particles and G2 particles can pass through objects because of the space and because they're being guided through. The second interaction is bouncing off. A particle can bounce off an object, and we see that clearly in mirrors. Light hits our face, the face image scatters to the mirror and bounces off the mirror. Actually, light is bouncing off my face, although I call it scattering because it sends a wide image, and it reflects off a mirror. These effects are bouncing, where the G1 particle bounces off the G1, or it bounces off the nucleon. G2 particle bounces off another G2, but ironically it passes through the G1 or the nucleon. When it does that, that sets up the method for G2 to be the second gravity. So light can bounce off of other particles. The third one is that it can be trapped. Now, by being trapped, I mean the G1 particle can enter an object and then orbit an atom or a molecule. And I've already discussed how G1 particles orbit. If it enters an atom or a molecule at the right speed, the right direction, with the right distance, it will orbit. I call that being trapped by. It can be trapped by. Now you might say, oh, well, wait a minute, Bob. The atom can only have so many electrons. In level 1, it's 2, and then it's 8, and then it's something else. It has to have each one of these levels. No, not in the particle model. Let me give you an example. Rub a balloon on a wall, and it will pick up, the traditional answer, it will pick up electrons. In the particle model, we're saying it picks up G1 particles. So where are these G1 particles that are hanging there in space? They're just sitting there waiting for a bus to come along and move them? No. The G1 particle in the wall that moves from the wall to the balloon was moving at speed c. If for some reason, a mechanical reason, it's broken loose and it leaves that atom, it's moving at speed c. It enters the balloon, and because of the material of the balloon, you have this possibility that it has the right speed, it has the right direction, and it's the right distance, and it will orbit. So in effect, the G1 particle moving at speed c in a wall moves at speed c across the interface, moves and orbits at speed c. It's not just hanging around like a person at the corner waiting for a bus. And you build up these charges, and these atoms are going to contain more and more G1 particles than they normally do. That's a slightly different model of the atom. But that's an example of how G1 particles are trapped by an object or an atom. So these are the types of interactions. And you will hear me talk about passing through. You will hear me talk about an atom, a G1 particle, as in a circuit, for example, going through a resistor, hitting an atom and scattering and bouncing off and reducing the flow of G1s through the circuit. You will hear me talk about mirrors bouncing. You will hear me talk about electrostatic charge that builds up in a glass rod. These happen all the time. And this is a good foundation for understanding particle-to-particle interaction. My name is Bob HIlster, and I am your particle model guru. Please tune in next time when I will explain how the particle model can explain the universe. Thank you for your attention.